In this video, we're going to minimize distance or time. It says Renee is staying in a cottage along a beautiful and straight shoreline. A point Q on the shoreline is located 3 kilometers east of the cottage, and an island is located 2 kilometers north of Q. And it says see the image below. So we can see that she's staying in a cottage. There's this point Q on the shoreline that is directly in line with the cottage in the X direction and in line with the island in the Y direction. And she's 3 kilometers from that point Q, and then that point Q is 2 kilometers from the island. It says Renee plans to travel from the cottage to the island by some combination of walking and swimming. So she could walk straight down the shoreline, then swim straight over to the island. That's one option, but there might be some quicker options. So she can start to swim at any point P between the cottage and the point Q. If she walks at a rate of 3 kilometers per hour and swims at a rate of 2 kilometers per hour, what is the minimum possible time it will take Renee to reach the island? So they want to know the minimum time. Let's write that down. Minimum time. That's what we're looking for. Now they give us this nice graph. Let's kind of write that a little bit different. Let's set some things equal to the time spent for Renee. So we know she's going to walk, so we're going to say that W is equal to the time spent walking. And then we also know that she's going to swim, so we'll say S is equal to time spent swimming. Okay. So then, I should have 2 M's there, swimming. All right. So then, what we want to do is, let's draw this cottage piece again, and then we'll just make the same graph, but we're going to label this differently. So we're going to assume that she's going to walk a little bit, maybe to like this point here. We don't know what that point is, but we know that we're going to call from this point to this point W. And then she's going to swim this distance. We know this distance right here is 2 kilometers. And then we know that this distance here would be the 3 kilometers. Okay? So this is 3 kilometers from this point all the way to point Q. This distance then would be 3 minus W. So we have 3 minus W here for the distance from this point where she starts to stops walking and starts swimming to this point Q. So this kind of gives you a little better description of what's happening in the problem. Now, we need to state that we know that velocity, because they give us velocities here, velocity is going to be distance divided by time. So in our case, we want to rewrite this by multiplying by time and dividing by v. So that means that we have time is actually distance divided by velocity. So in our case, we can write some equations now from this. She spends a little bit of time walking, and she's walking at 3 kilometers per hour. So let's go ahead and define that. We're going to say velocity walking is 3 kilometers per hour, and velocity swimming is 2 kilometers per hour. So when we say, let's go ahead and write this as the time spent walking is going to equal the distance that she travels, which we already called that W. So actually I said time spent walking. W is actually, this is distance spent walking. So this is distance. And then, let's see. and then y is going to be, s is going to be the distance spent swimming. So the time walking would be w, which is the distance. I kept representing that as distance, but I wrote time there. That was dumb. So anyways, we're going to have the time of spent walking is going to be our distance, which is w, divided by the velocity, which is 3 kilometers per hour. So we're going to say w over 3. And the time spent swimming is going to equal s divided by, we're going to divide that by the velocity, which is 2. So what that means is we can say that our total time is going to equal, so time total would equal the time spent walking plus the time spent swimming, which in our case is going to be w over 3 plus s over 2. Now, we need to get this down to where we have just one variable for this equation. So to do that, we're going to look at this triangle that we have created here. So we can figure out what s is in relation to the other two side lengths using the Pythagorean theorem. We can say that s squared is equal to 2 squared plus 3 minus w squared. So then we can say that this is actually equal to s is equal to the root of 4 plus 3 minus w squared. So then I can resubstitute that in here, and I can write this as the time total is equal to w over, we're going to actually write this as 1/3 w, and then plus 1/2, and then we'll substitute that in for s, so that'd be 1/2 times root 4 plus 3 minus w squared. Now let's go ahead and simplify that just a little bit so we can find the derivative easily. So we're going to say that the time total is going to equal 1/3 w plus 1/2. If I distribute the 3 minus w squared, I'm going to go ahead and do that here. That's going to equal 9 minus 3w minus 3w, and then negative w times negative w will be plus w squared. So you end up with w squared minus 6w plus 9. So when I take that, I plug it in here, and I add the 4 to it, I actually end up with the root of w squared minus 6w plus 13 inside there. Okay, now we're going to go ahead and take the derivative. So one thing we want to do before we take the derivative is we want to notice that we have a restriction for this t of x value. We have a restriction on our w value. So the restriction for our w value, so w must be, we're going to say 0 to 3. And the reason we say 0 to 3 is the shoreline is only 3 kilometers long. So w, when we go to solve this, when we take the derivative and solve this, w is going to have to be between 0 and 3 kilometers. That's going to be our important piece that we're going to use when we go to solve this. We have to take the derivative first, set it equal to 0 to find the max or min. But our max or min better be within 0 or 0 and 3, because we can't be less than 0, because obviously we're going to have to walk, and or the smallest amount of walking is 0. And then we can't be more than 3 kilometers, because if we go past 3 kilometers, we go past point Q. So let's go ahead and take the derivative now. So we're going to say that t prime is going to equal, we're going to say t prime of w is going to equal Derivative of 1/3 w would just be 1/3 plus the derivative of this. Remember, this is all to the half power, so bring a half to the front. That'd be 1/4 w squared minus 6w plus 13 to the negative 1/2 times the derivative with respect to w of w squared minus 6w plus 13. So when we do the derivative of this, we're going to end up with t prime of w is equal to, derivative here would be 2w minus 6. So we're going to end up with 1/3 plus 1/4 times 2w minus 6 w squared minus 6w plus 13 to the negative 1/2. So then what we want to do is we want to start simplifying this a little bit. So to simplify this, I'm going to write this as equals, if I factor a 2 out of 2w minus 6, that would make this 2/4, which would be 1/2. So I'm going to end up with 1/3 plus, and then that'll be 1/2 times, and then if I go ahead and write this, this would be times w minus 3, and then times, this is 1/root w squared minus 6w plus 13. Now I'm going to set all this equal to 0, so I'm going to have to slide this up a little bit. So all this is equal to 0, and I get 1/3 plus, I can rewrite this, this would be w minus 3 over 2 root w squared minus 6w plus 13. And then I'm going to start solving this. So let's subtract the 1/3 over. We get negative 1/3 is equal to w minus 3 over 2 root w squared minus 6w plus 13. Now I'm going to multiply each side by this 2 root w squared minus 6w plus 13. So we end up with negative 2/3 root w squared minus 6w plus 13 is equal to w minus 3. I'm going to now square each side. So I'm going to multiply, take this negative 2/3 root w squared minus 6w plus 13, and I'm going to square this side, and I'm going to do the same thing to w minus 3 squared. When I square the left side, I get 4/9 times, this will be just, if I square this piece, this is w squared minus 6w plus 13. When I square w minus 3 squared, when I square w minus 3, I get w squared minus 6w plus 9. Now I have a quadratic that I can solve here, so I'm going to distribute the 4/9 to each piece. Actually, what I'm going to do is I'm going to multiply everything by 9. So I'm going to multiply this side by 9, and then that'll multiply these 3 pieces by 9. So I end up with 4 w squared minus 6w plus 13 equals, this would be 9w squared minus 54w plus 81. Distribute the 4, I get 4w squared minus 24w plus 4 times 13 is going to be 52 equals 9w squared minus 54w plus 81. Then subtract 4w squared on each side. I'm going to add the 24w. And I'm going to subtract 52. It's going to give us 0 on the left side equals 5w squared minus 30w. And then 81 minus 52 is 29. So then I'm going to take the, let's see, I'm going to use the quadratic formula now. So to use the quadratic formula, I'm going to say that w is equal to negative b plus minus root b squared minus 4ac all over 2a. So we're going to get w equals negative 30, so we have negative 30 here, plus minus root negative 30 squared minus 4 times a times c all over 2 times 5, so 2 times 5 here. All right. Slide that up a little. Switch this out for a little pink. So let's rewrite this over here. I'm going to just kind of point this arrow right there. And we're going to get w is equal to 30 plus minus, this would be root of, let's put that in there, so 30 times 2, 30 squared, minus 4 times 5 times 29. You get root 320 over 10. So then we're going to say that w is equal to root of 320. I don't see a reason to necessarily reduce that. Said round to the nearest hundredth of an hour. So we're going to be okay here. We're going to say root 320 over 10, or w is equal to 30 minus root 320 over 10. So w is going to equal 4.788, or 3.03. So let's see. I feel like I messed something up here. Because W is supposed to be between 0 and 3. We're supposed to have one value between 0 and 3. Let's see. Oh, I screwed up. Okay. This is not 3.03. I divided by 4 here in my calculator. I should have divided by 10. Yeah, that makes sense. All right, so we got 1.211 for W. Okay. So we got 1.211. That's within our domain 0 to 3 here. So this one does not work because it's outside the domain. Now what we need to do is we need to check the endpoints and check this W value to see which of these gives you we're trying to minimize the possible time, which one gives you the least time. So we're going to say we want to check T, the original equation, of actually let's do T of 0. We're going to do T of 1.211, and we're going to do T of 3. Now the original equation for T was equal to 1/3 W plus 1/2, it's written right here, root W squared minus 6W plus 13. So that's the original equation for T. So we're going to call that T of X, or T of W. Write that better. This is T of W. So that's the original equation. I'm going to plug 0 into this and see what we end up with. So if we go, and I'm going to plug all that in the calculator. So we're going to say 1/3 X plus 1/2 square root of X squared minus 6X plus 13. Okay, that equation's right. So then I need to plug in 0, so 0, store it as X. This is 1.8. We're going to say 1.80, and that would be 1.80 hours. Let's do 1.21 now. So 1.211 store as X. Okay, that's 1.75 hours. So that's smaller, so this one's out already. So this one can't be the minimal. So then let's do T of 3. So we're going to plug in 3, store as X. That's 2 hours. So this is the minimum time. This is the minimum time that it would take us to basically walk a distance W. What was W? W was 1.211. So we'd walk 1.211 here, and then we'd start to swim straight to the island up above. Hopefully, I don't think you can see that. So if I go and slide this down a little, and I look at our times, this W value is 1.211. So I would walk basically 1.21 kilometers, and then I would start swimming out to the island. And that is the shortest amount of time, 1.71 hours versus 1.8 hours if I just start swimming right away. And then it would take me 2 hours if I walked the 3 kilometers, then swam.